Hello everyone. So last class we have solved some of the numericals. So today we'll be trying to solve rest of the numericals, right? So we have discussed some of the formulae, right? After that we discussed about uh, this many numericals, right? So up to this we have completed. So let us try to solve from the question number 6, right? So here the question is saying that air is compressed in a cylinder such that the volume changes from 0.2 to 0.02 meter cube, right? So basically initial volume and the final volume is given to us, and obviously there is a piston cylinder arrangement maybe, right? And here your gas, right? So the air, so gas is here air, and it is being basically compressed from this volume. I am writing this is as V1, and this is the volume, this is V2, right? So basically we are compressing the gas. As a result of that this volume is decreasing, right? And the initial pressure is given to us as 200 kilopascal. So I can write this is as the P1, okay? And if the pressure is constant, find the approximate work, right? So if pressure is remaining constant, that simply means I can write down that P1 is equal to P2. In this case we have to find out the work interaction, that is work 1 to 2 will be equal to how much. That is what we need to find out, right? Okay, so what are the given datas over here? Here V1 is given to us as 0.2 meter cube, V2 is given to us as 0.02 meter cube, and P1, which is equal to P2, it is given to us as 200 kilopascal, right? And this is a process of constant pressure, right? Here process is P is equal to constant. This is the your isobaric process, right? And for isobaric process, if we be trying to find out the work, so we know this is W is equal to what, integration of P dV from the state point 1 to state point 2, and if this is constant then simply we can take it out, right? And integration from state point 1, that is V1 to V2 and dV. So I can write P integration of dV, I can write as V from V1 to V2. So I can write P times V2 minus V1, right? So this is the formula for work interaction for a constant pressure process. So we have to find out this work. So W1 to 2, that will be equal to this pressure which is given to us as this 200 kilopascal. So I am putting that 200 multiplied by this is V2 minus V1. So V2 is given to us as 0.02 minus V1 was 0.2, right? So it will be calculating this value. So let me calculate 200 times 0.02 minus 2, right? Sorry, 0.2. So here we will be getting us minus 36, and obviously it will be in terms of kilojoule because we have put this particular pressure value in terms of kilopascal. So we'll be getting this value in kilojoule. That simply means here we are getting this as the negative sign because we are supplying the work to the system, right? So that is basically it is significance, right? So the your negative sign, it is basically signifying that work is given to the system, right? So work and interaction will be equal to minus 36 kilojoule. Okay, I hope it is clear. Let us move further. So now here is a question that it is saying, so let me use the red color. Okay, so a system executes a cycle during which there are 4 heat transfer. Okay, so basically a system, it is consisting of a cycle. Cycle simply means there will be number of processes, right? And in each process there is some heat interaction. right? As four heat interaction is there. So in each process we are having some amount of heat interaction is there, right? So Q12 is given to us as 220 kilojoule. Q23 it is given to us as minus 25 kilojoule. Q34, that simply means the heat interaction during 3 to 4 process, that is given to us as minus 180 kilojoule, and 421 it is given to us as 50 kilojoule, right? The work during the this is sorry so work during the processes is W12, this is given, 23 is given, 34 is given, right? And it is asking to find out the work done during process 421, right? So if I'll be trying to plot in any property diagram, let this is any property diagram, let this is property 1 and this is property 2. So there are basically 4 processes. I am plotting any random property, right? Let this is state point 1, 2, 3 and 4, right? And in each processes there are basically some interactions are up there, right? So if we'll be talking about the interaction, like there is some heat interaction and there is some work interaction, right? So there is some heat interaction, there is some work interaction. In all the processes we are having or such interactions, right? So in all the processes we are given with the heat interactions and work interaction, but in the process 421 only we are known with the heat interaction, but we do not know the value of work interaction. So we have to find out this W, this 421, right? So we have to find out this W421, okay? And we know basically we are going to apply the first law of thermodynamics, which means the amount of energy which is being added to a system, that should be equal to the amount of energy which will be getting from the system, okay? And when basically this first law will be applied to any closed cycle, in that case I can write some the cyclic integral of heat, that will be equal to the cyclic integral of work. That simply means I can write down the Q12 plus Q23 plus Q34 plus Q421, that should be equal to W122 plus W223 plus W324 plus W421, okay? So all the terms are given to us. So Q122 is given to us as 220 plus Q23 given as minus 25 plus 34 is given to us as minus 180 plus this is 50, right? And that will be equal to 15 plus minus 10 plus 60 plus W421, right? So simply we have to solve and we can find out the value of W421. So that will be equal to, let me calculate, 220 minus 25 minus 180 plus 50 minus 15 plus 10 minus 60, so that will be equal to 0, right? So here we are getting this W421, that is equal to 0. That simply means there is no work interaction during this process, right? This process there is during 421 there is no work interaction, okay? So here answer will be equal to 0, okay? Let us move further, okay? So already we have solved some question related to this, so you can try it by yourself. So if you will be facing any issue, you can ask, we can solve it, right? Moving further, okay? So here it is saying that a gas goes through a process given by this particular equation, right? So here it is given as PV raised to the power 2 is equal to constant. That simply means we can relate with this particular equation, that is PV raised to the power n equal to constant, where in this case your n is replaced by 2. So this is a kind of your polytropic process, right? So it expands from a state 1 of 350 kilopascal and 0.049 meter cube, right? So basically it is giving some data about the state point 1, right, where I can write, so given data. So about state point 1, it is giving that P1, so it is given to us as your 350 kilopascal, right? And V1 it is also given, so V1 it is your 0.049 meter cube. So to a final pressure of this 150 kilopascal, that simply means it is basically expanding, right? And due to expansion process, your pressure is basically decreasing, right? So here P1 is getting changed to P2, where P2 is your 150 kilopascal, right? So initially pressure was 350 kilopascal. Now it has changed to a lower value we can say, that is 150 kilopascal, right? And we need to find out the work delivered during the process, right? So because this is a expansion process, that simply means your system is doing some work. It is basically giving some work to the surrounding, and we have to find out that particular value, how much amount of work it will be delivering to the surrounding, right? So obviously we'll be calculating this work interaction, okay? And we know, so the equation which is given to us for this particular process, that is PV raised to the power 2, that is equal to constant, and then already we know this n is equal to 2 over here. And basically this is a polytropic process with the polytropic index is 2, right? And for the polytropic process already we have derived the work interaction value, so that is P1 V1 minus P2 V2 divided by n minus 1, right? So here let us try to understand if all the data are given to us or not, right? So we are given with the values of P1 and V1, right? And we are given with the data of P2, but we do not know the value of V2, right? So to put the values in this particular equation, we should know the value of V2, right? And obviously n is there, so there is no issue related to that, right? So to find out the value of n2, we have to use some of the equations, that is the your polytropic equation, right? So what is the polytropic equation? Basically this one, right? I can write down this as your P1 V1 square will be equal to P2 V2 square, right? And in this particular equation there is only one unknown, that is V2, right? So let us try to calculate that. I can write P1 by P2, that will be equal to P2 by V1 square, right? And from here we will be trying to find out the value of V2, then I can write that this will be under root P1 by P2 into V1, right? So now let us put all the values which is there. So P2 we can find out as P1 is given to us as 350 divided by P2 is given to us as 150 under root of that into V1, that is 0.049, right? So calculate, let us try to calculate this one. So under root 350 divided by 150 into how much, that is 0.049, right? So if we'll be doing this calculation, we'll be getting as 0.074 0.0748. So let us write this as a 0.75, right? So we can write this is as 0.075, and obviously will be getting, this is as in meter cube. So V2 will be equal to this value. Okay, now we are having with all these values over here. Now we can put this value of V2 in this particular equation. So let us put and try to find out that. So here E1, it is given to us as 350 into V1, that is 0.049, okay, minus P2, that is 150 into 0.075 divided by N, that is 2 minus 1, right? So let us try to calculate that. That is 350 multiplied by 0.049, that is equal to, I can write 17.15 minus 150 multiplied by 0.075. So I will be getting 11.25 and divided by 1. So it will be calculating that. Is 17.15. Will be getting as minus, sorry, plus 5.9, and obviously what will be the unit? So we are putting this pressure in terms of kilopascal, so here we will be getting kilojoule, right? So 5.9 kilojoule will be the amount of work which will be getting from this particular system, right? So another thing, here we are getting a positive, that simply means we are getting the work from this particular system, right? I hope it is clear. Let us move further towards the next question. Okay, so now here it is a question which is saying that what is the rise in temperature of 80 liters of water in 40 minutes by a heater of 2 kilowatt, right? If whole of the heater, right, whole of the heater energy, it is used to raise the water temperature. That simply means there is a container, right, and it is having some water inside it, right? We have connected a heater to it, right, and this heater is giving some amount of energy. Obviously in the form of work we are giving the energy, that is electrical energy, to this particular system, right? We are considering this is as my system, right, and this much amount of energy we are supplying to this particular system, right? And by using this amount of energy, our system is basically changing the temperature of water, right? So we are assuming that there is no loss of energy. Whatever amount of energy we are supplying to the system, that is basically used to raise the temperature of the water. That simply means we can say that the amount of energy which we are supplying, that is consumed in the temperature rise of the water. Okay, so basically we are converting this particular amount of energy into the internal energy of water, right? So we are given with this much work, right? W, we are supplying this kilowatt, right? Okay, so work per unit time, we can say. So we know the unit of work is what? This is your joule, right? Here we are writing this in terms of watt, that means we are talking about the power, right? So per unit time, we are supplying this much amount of kilojoule, right? This much kilojoule of heat, sorry, this much kilojoule of work to the system, right? And the same amount of work, it is being basically used to increase the temperature of water, right? Okay, so now we can write down, basically due to this work interaction there will be increase in the internal energy, and we are assuming there is no loss, so I can write this work per unit time, that will be equal to the internal energy change per unit time, that is we can write down du per time. right? Okay, and we can write down this du as what, mcv dt. Okay, and obviously time is there. Okay, and cv is for the water, f is cp and cv. So that is basically same, that is cp value here will be getting as, basically c value will be getting as 4.2 kilojoule per kg Kelvin, right? So already we have used this particular value in one of the previous problem, right? So here see, okay, another thing here you may matlab you may get doubt, that is cp and cv, right? So basically these two values are not different in case of the water, right? So we'll be having different values of cp and cv in the case of gas only, right? But these two values will be equal when we are talking about the liquid or solid, right? So for liquid solid there is only one specific heat, that is C, right? So when we are talking about this particular liquid, that is water, then in that case we have to simply consider the your that is C value, right? mc dt obviously, and T is there. Okay, so we know this particular value, and this is equal to this term, right? Where we want to find out this particular value, that simply means we should know all these terms, right? So let us check what are the values are known to us. We know the value of C, there is no issue. Okay, and here it is given how much time we are basically using, right? So we know this time value also, and another thing we have to know this mass. So what is the amount of mass is there, that we have to find out, right? Okay, so is there any data related to mass? Here we are given with this particular 80 liter, and what is this 80 liter? This is the volume of the water, right? And if we know the volume, can we find out the mass? Just try to think about that. Okay, so if we know the value of volume of liquid, so can we find out the mass? Obviously we can find out, because this is, here we are talking about the water, right? And in case of your water, we know the density of water, right? So what is the density of water? That is equal to 1000 kg per meter cube, right? And what is the density? Density of water equal to mass per volume, right? And if we know this value, and if we know this value, then obviously we can find out the mass, right? So mass can be found out by density of water, that is 10 to the power 3 into this volume, right? So volume, it is given in terms of liter, right? So V is given to us as 80 liter, and if we will be trying to convert that into meter cube, then I can write 80 into 10 to the power minus 3 meter cube, right? So I'll be putting this particular value over here. So this will be equal to 80 times 10 to the power 3, obviously minus this will be your value, right? And if we'll be calculating this value, we'll be getting mass as 80 kg, right? So you know all other values over here, and simply you have to put it now in this particular equation and try to find out, right? So it will be trying to solve. So let me erase some of the portions. Okay, now if I can write, this is 2 kilowatt obviously, and that will be equal to mass, that is 80 kg. Okay, and C, that is 4.2. so we have kept in this side kilo, so we can keep this is as kilojoule per kg Kelvin, and 2 dt divided by time is given to us as 40 minute, but we have to keep we have to put in second, right? So we'll be adding the 40 multiplied by this 60, right? So it will be converted into second. So now rest things we can calculate. So change in temperature, that will be equal to 2 Okay, so here this can be cancelled, 2 and this 2 can be cancelled, right? So now I can write, so dt will be equal to 60 divided by 4.2, right? So let us try to find out that change in temperature, that will be equal to 60 divided by 4.2. So we'll be getting us 14.14.3 degrees centigrade, right? So this is the value of temperature rise will be there in case of this particular condition, right? So this much amount of temperature rise will be there. Okay, so I hope this is clear. Let us move towards the next question. Okay, now, so here it is saying that a mass of gas is compressed in a quasi-static process from 80 kilopascal 0.1 meter cube to 0.4 megapascal and 0.03 meter cube, right? So basically there is a compression process, and it is happening from state point 1 to state point 2, right? So corresponding to state point 1, we are given with the pressure value, that is 80 kilopascal, right? We are given with the volume, that is B1, that is 0.1 meter cube, right? Okay, similarly corresponding to state point 2, we are given with the pressure value P2, it is given to us as 0.4 meter cube, and also we are given with the volume value, that is P2, that is 0.03 meter cube. So here actually we are talking about the compression process, and from the data also we can see that V1 it is basically decreasing. Okay, so basically volume is decreasing and pressure is okay. So I think we have made some mistake over here, right? So P2 is given to us as 0.4 megapascal, right? So this is the unit of pressure, megapascal. Okay, okay, so I was talking about this. So pressure is basically increased and the volume has been decreased, so obviously this is a compression process, right? Okay, so assuming that the pressure and volume are related by this particular equation, where PV raised to the power gamma is equal to constant, we need to find out the work done by the system, right? Okay, so when we are talking about this particular polytropic process, to find out the work done value, we have to use this particular formula, that is W1 to 2, that will be equal to P1 V1 minus P2 V2 divided by n minus 1, right? So here from the given data we can get to know that all these values are given to us other than this particular n, right? So we do not know the value of n over here, that is the polytropic index, right? So we have to find out the value of n for the further calculation. Okay, now, so this is the equation which is given to us, so we can put that, we can write P1 V1 raised to the power n, that will be equal to P2 V2 raised to the power n. Now let us do the same thing, I can write P1 by P2, that will be equal to your V2 by V1 raised to the power n, right? So now we are basically interested to find out the value of n, right? So if we want to find out the value of n, let us take ln in both the sides. So you can write logarithm, natural logarithm of p1 by p2, that will be equal to ln v2 by v1 raised to the power n, right? And here we know that ln a to the power x will be equal to x ln a, right? So by using this particular property, we can basically bring this particular n term to this to here, right? So I can write n ln v2 by v1, right? So now you can find out the value of n. So n will be equal to your ln p1 by p2 divided by ln v2 by v1, right? So now simply we have to put the values of pressure and volume in this particular equation, and we can find out the value of n, right? So let us do that. Ln p1 by p2, that is simply means 80. So obviously here it is in the terms of kilopascal, right? So we have to convert at least to 1 unit, right? So let us convert this into kilopascal. So obviously this will be 0.4 times 10 to the power 6 in, that is your pascal. So let me write it, 0.4 into 10 to the power 6 pascal. So let us use another color so that okay. So here I can write 0.4 into 10 to the power 6 pascal, and obviously I can write 0.4 and I want to convert it into kilopascal, right? So here 10 to the power 3 will be consumed for kilo, and another 10 to the power 3 will be there, right? Another 10 to the power 3 multiplied by 0.4, so I can write 400. Okay, so 400 kilopascal, right? So basically 0.4 megapascal will be equal to 400 kilopascal, right? So here you can see pressure is increased from 80 kilopascal to 400 kilopascal. Now we'll be using these values over here, 80 divided by 400. Okay, now divided by again ln v2 by v1. So v2 is there 0.3 and v1 is there 0.1, sorry it is 0.03, right? So 0.03 divided by 0.1. Okay, so now let us calculate this one. Ln 80 divided by 400 divided by again ln 0.03 divided by 0.1, right? So we're getting this value of n as 1.336. Here we can write 1.337, right? 1.337. So this is the value of n, right? So now we got all these values of p1, v1, p2, v2 and n. So now simply we have to put in the equation and we have to find out the answer, right? So I can write w1 to 2, that will be equal to p1, which is 80, into v1, which is 0.1, and we're putting the value of pressure in kilopascal, right? Okay, and p2, this is 400 into v2, that is 0.03, divided by the n value we got now is 1.337. Okay, so let us calculate this one. So here this is 80 into 0.1 minus 400 into 0.03 divided by, okay, another mistake here, 1 point, here this is 1, right? N minus 1, so here 1.337 minus 1, that is 0.337, right? So here we are getting as negative of 11.87. Obviously it will be in terms of kilojoule. Okay, again here you can see we are getting a negative sign. Okay, it was intuitive because we are doing a compression process, right? So because of this compression we have to supply the work, so that is why here we are getting the negative sign. Okay, so I hope it is clear. Let us move towards the next question, right? So here you can see, I think this is a quite similar question to the previous one, so I am not solving it, you can try it by yourself, right? So okay, now this is another question. I hope this is the question which was there in the your exam, right? Modular test, it was there, right? Okay, So we have to calculate the quantities of work if the initial pressure and volume is given. So this is P1 and this is V1, and the final volume is given, and this is V2, right? Okay. The process is non-flow reversible. So we are talking about the reversible process, and this is a non-flow. That simply means it is a closed system, right? It is not a flow process. That simply means the gas is not flowing anywhere, right? Okay. So if the pressure is constant, then what will be the work done, right? So if pressure is constant, then in that case W work done, that is W will be equal to E times V2 minus V1, right? So I'm not calculating this one, you can try it by yourself. So pressure is given here 15 bar. So whenever you will be putting, you have to convert this bar into a particular unit, right? So we may convert this into kilopascal, because basically we want to get the work in terms of kilojoule. So that is why we will be converting this pressure into kilopascal, right? So if you want to do that, so I can write P1 will be equal to 15 bar, and your 15 bar will be replaced by 10 to the power 5 Pascal, and out of this 10 to the power 5, your kilo, basically 10 to the power 3 will be consumed for the kilo, and 10 to the power 2, 10 square will be there. So here I will be getting 1500 kilo Pascal. Okay, so I hope you got to know how basically we are converting the units of pressure, right? Okay, so you will be putting the value of pressure and volume V2, V1, both these are given, so you can find out the value of work interaction, right? So 2 when volume is constant, right? So when volume is constant, in that case basically there is no work interaction, because if V1 is this one and V2 is also this one, so W, basically there is no change in volume, so the integral of this dV will be equal to 0. So here we will be getting W equal to 0. For 3, when it is saying that PV is equal to constant, right? So PV is equal to constant, that simply means we can write, basically it is a constant temperature process, right? We know from this particular your Boyle's law, that is at constant temperature pressure and volume, they are inversely related, and from here we got to know this is PV equal to constant. So this is the equation for your constant temperature process, and for constant temperature process what is the work? So that is equal to P, that is PV, that is P1 V1 ln V1 by P2, right? So you can use this one, or we can replace this by V2 by V1, right? Because here volume for both these points are given, so you can put these two values over here and you can find out the work interaction. I hope it is clear. Now fourth one, so where PV raised to the power n equal to constant, so already we have solved two questions related to that. So if PV raised to the power n equal to constant and n value is given over here, so work interaction formula will be equal to P1 V1 minus P2 V2 divided by n minus 1, right? So thing is that you have to find out the pressure over here, because initial pressure and initial volume is given, final volume is given, but final pressure is not there. So you have to find out the P2 first, then you have to use this value in this particular equation. Okay, and another thing, fifth one, here PV raised to the power gamma is equal to constant. So here gamma value it is also given 1.4. So here PV raised to the power gamma, so you have to use the gamma value as 1.4, this is equal to constant, right? Here gamma is equal to 1.4, so you have to use this particular value and find out the value of pressure P2, and after finding this value of pressure you have to use this in this particular equation, right? So that is equal to v1 v1 minus v2 v2 divided by gamma minus 1, right? So again, in this equation you can put all these values and you can find out the work interaction for all these processes. I hope it is clear, and with this we have solved some of the questions. Okay, I hope you could able to understand all these things. If you are having any doubt, you are free to ask. Okay.